Well, you've guessed it, folks. It's a base station, and it's the Harvard H407. And I like these equally to the 134 chassis ones. These are the 002F chassis, all Cybernet made in Japan, and I find these work very well. So before we open it up, let's do a performance test. I think he's bought this off eBay in a box. I think it was something stupid like £45. And I said to him, because he ran it past me, I said, well, if you don't buy it, I will. So you know, like 30 minutes to make your mind up. So, yeah, it's even come in its original box. I don't know about the mic. Right, let's plug in the test equipment. What I need is a microphone, so let's hope that's wired Cybernet. Seems that way. So, Harvard H407. So let's switch on some cameras onto picture in picture. So we're on the 3 watt scale, so if it's 3 watts it's full scale deflection. We must be on low power. We are. So it's more than 3 watts, it's actually 3.6 watts. It's doing, let's go over to the frequency counter. It's doing 27, 7, what channel are we on? That's better, more like it. It's still 3.6 watts. 20.7, 79040. I think that's within spec. I'd have to look that up, but it needs to pull up if it will. It'll certainly pull up more than that, I'm sure. Deviation. So we want it to be between 2.2 and very maximum of 2.5. So we're looking at a reading round about there. Wallow. It's about 2.6. It's about right. Just need to trim that a little tiny bit. So that's our transmit. Now on receive, what I will be doing, whether he likes it or not, is going through the power supply, because these sets are 38 years old and the capacitors are not likely to be like factory fresh, are they? So we will change the capacitors in the power supply, and then we'll again look at the power, because we may well find that the power comes straight up to 4 watts just by changing the power supply capacitors. It just might not be able to give that 1.2 amps for transmit. So receive, let's have a look at that. So I've got Mr. Chippy's service all here. I will be in trouble. Pinched it off his bench yesterday. Okay, so we're spot on frequency. That's where that's the signal generator now showing. Just going back to that deviation, because I've just discovered the mic gain wasn't at full. Wallow, it's 3.2. It's over the top. So, where are we? We're looking at the receiver. We'll go over to the synad meter. We'd better plug that in, otherwise we're not going to get anything showing on it, are we? I've got a synad meter to align. I did have a go at it, but I've had to order another test instrument. I don't normally do service work on test gear, but he's a regular trade customer. I thought I'd try and help him. Okay. So for 12 dB, let's go on the other scale. One RX. Okay, we're between scales as ever. We're always between scales. So it's 1.05 microvolts on that scale. And on this scale, it's about 1.1. So we'll put 1.05 microvolts for 12 dB. Cyanide. So that this radio is capable of better than that. Even if it's a bit better. I've seen these down to 0.28, but not all samples are going to exceed the manufacturer's specification, which I think is about 0.7. So with that, we will switch it off, open it up, and start changing capacitors in the power supply. So I'll be back. So exactly a week later, we finally got the part. The capacitor has been fitted. What it is, I ordered it last Friday. When you're ordering from RS Components, you expect next day. Next day is Monday because weekend doesn't count. Monday came, turns out instead of using Parcel Force, they've moved over to using DHL. And at 7:30 in the evening, the tracking came up as driver can't find your address. So Tuesday came and it hadn't gone on the van, so I had to moan to RS Components to say where is it. Then it went on the van, and on Wednesday it said you are drop off number 75. Well, number 75 never happened, and it came down on the tracking as van broke down. I think that's a load of bull. Who thinks that's a load of bull? Good, I think you all do. That's one of these things where they're going to report back to RS and say, well, it isn't our fault. So Thursday it said you'll drop number 18, and so lo and behold, about 1 o'clock a DHL delivery happened, and I've just realised I've forgotten to screw the heatsink board back into the radio, so we better do that. See, that's what happens when you leave things, and I can't take it off. It means putting it back together if we start taking it off the bench, and that's costly in time, and it's not the customer's fault. And so, see if I can line that up. So really, really annoying. So I hope that subsequent DHL deliveries won't be delayed like that. The whole idea of using RS Components is top quality and speed. I have to admit that something I would have ordered from RS, I decided to order from Farnell, and that arrived 9:30 the next day, as I would have expected. But the Farnell cost of that part was 56 pence as opposed to RS's 45 pence. So that means then the customer's paying more unnecessarily just because I'm scared of not getting the part in time. So let's hope let's hope that improves. Do we all remember when the UK distribution for Kentucky Fried Chicken changed distribution, and it was an absolute nightmare. Right, that's that one in. So now we've got one in. I won't tighten that up so we can line up the other one easily. It's just you've got this transformer in the way. It's probably fitted later. So we've changed the 3300 microfarad capacitor, which is what we've been waiting for, which is that one down there. And we've changed the two capacitors, the two electrolytics here on the regulator board. So now these are 38, 39, 40 years old. That's the thing to do, switch on. Well, it hasn't blown up, and that's a good start. So we'll get the meter out. I borrowed the leads from the meter, and where did I put them? I borrowed them for another... Aha, that's one of them. I borrowed them for our oscilloscope, because it's got a built-in, that little LCD oscilloscope I use has got a built-in meter. Right, so what we want, I'll put the meter in the middle of the radio. What we're looking for is 13.8 volts. So I didn't want to adjust the power supply with the old capacitors in, so we'll do it this way. So on the positive of the capacitor, we've got just under 20 volts, so that's our unregulated voltage, and our regulated voltage is going to be somewhere. $13.77. I'm just going to pop this into transmit. We'll see how that drops. 13. It doesn't. Excellent. I don't need to adjust that, but just for the record, the one and only preset on that regulator board. Just get my fingers in such a way that hopefully the camera can still see it. We have that one and only preset down there. And we can vary that accordingly. I'll probably never get it back as near as it was. Hmm. 13.79. So that's that done. The next thing we want to check the VCO voltage, and so I'll need the service manual for that because I have a memory like a sieve, and it doesn't matter how many I've done, I'll still need to look at the service manual. So what I do remember is we're looking at this capacitor, and I think we're looking at the far side of it, and at the moment we've got 2 point whatever. So this is done on different channels. Using the Amstrad service manual because it's the only one we've got with this chassis. We've got the Fidelity 2001 as well. So what we're doing is we are selecting channel 40, and we're looking for point 2 in the service manual. Channel 1, select and adjust for 2 volts on receive. Okay, 2 volts on receive. Going to transmit, adjust CT1 for 2 volts. So 2 volts on receive. Hopping around. I'm just going to waggle the trimmer around. They can get dirt in them. We'll start again. Receive. Transmit. Receive. Transmit. We'll keep that high for now and just see how that plays out. And then staying on transmit, they want you to check it on channel 40 that it's in the 4 to 5 volt region. That's where I misread it. So staying on transmit, well, it's not quite. I'm happy it's in lock. They don't always set up exactly as the manual says, but with experience, you know that that's in lock. So the customer isn't going to have any trouble there. Now, remembering to go back to channel 20, I'm going to just make sure the thing's on frequency. So let's move the camera over to the frequency counter. Yeah, it was low, wasn't it? When we looked at it last week, it was low. So what we need to do is to try and pull that up. I don't think it's out of spec yet. Hasn't gone that far, but it isn't far off. So it's 27. It should be 125. So we're going to bring that trimmer coil upwards, and fingers crossed that it goes a bit closer. That's as close as it's going to go. 110 should be 125. It doesn't make any difference. That isn't off frequency. So when this radio gets older, eventually it's going to get to a stage where the quartz reference crystal, the 10.24 crystal, there is going to have to be replaced. But as it is at the moment, it's nearly there, and it's quite good enough. So that's done that, and I'll make a note that it's 2779110. So that's brought that up well. So we need to go through and see what power we're getting now on this radio. So go back to the meter. Don't know why my camera's not in correct position, but who knows? Mice must have moved it. So we're now looking, it was 3.6 watts, there's 4, it's now 3.7 watts. So sorting the power supply out has just, brought it up that little bit. So we'll pop through the transmit lineup. Change tools. Now here we go. Change tools again for one that actually fits. Is this broken? No, 3.7 is its optimum position. So I'm just going to check, because that could be the 55 megasecond harmonic trap. So RF check. They want it to be between 3.7 and 4 watts. Well, it is at 3.7, so it isn't out of spec, even if it's disappointing. So let's just check. T2, 3, 4. Two, 3, 4, L4, L8. L4, L8 is one of the power adjustments, so that's fair enough. We can do that. See if we can just bring it up that little bit more. Oh yes, we can. Just doing 4 watts. It's absolutely on the dot. So something we could do, if that hadn't worked, we can slightly alter the dropper or ballast resistor, whatever you want to call it there. Now we see these sets removed. Well, if that's been shorted out, chances are the very expensive, hard to get output transistor, the Mitsubishi 2SC2166, and all the ones for sale seem to be fake, because they stopped making these before 2000. So when you see them on eBay all nice and shiny, well, they've got to be fake, because they'd be tarnished, wouldn't they, if they're 20 years old. So you see, there's even YouTube videos. This is why we started doing these videos, because you get some Wally taking these out and shorting them out. And, oh, look, my radio does 12 watts. Well, might do 7 for about 30 seconds. So we can change that value slightly. Just to tell you, here we are. We actually change now. If you look, that's a 3-watt resistor. Well, we fit a 7-watt resistor, and it's supposed to be 3.6 ohms. So really, I feel safe to take that down as low as 2.7 ohms for it still not to burn out the output transistor. But that's what we would do if we couldn't get the power up. And we have a bag here with these type of resistors in slightly different values to when that happens. But this set has gone. It says it's supposed to be doing 3.7 to 4 watts, and it was doing 3.7 while we sorted the power supply out, and now it's doing 4. So now it's cooled down. Let's key it up, and it's bang on the money. It's bang on the 4. That's excellent. So I'm glad we've sorted that out. He's going to get all of an extra 100 yards now, bring it up from 3.6 to 4. RF meter. Oh, and yeah, let's check it does low power. It isn't adjustable, but low power, the radio is doing 0.31. Should be 400 milliwatts. It isn't adjustable. There's no point messing about with resistor values to change it. Who's going to use low power on a base station? But it is working, and it can be useful if you were just wanting to talk around the house with some walkie-talkies, and you don't want to be broadcasting your messages all over the place. Then you can restrict your range by doing that, which is a good idea. So that works. So we need to now check that the meter the meter preset is RV1. I think it's that one there. It is. So we just need the meter to say that it's also doing 4 watts. At the moment, it's actually about right. So we've got the dummy load, of course, with the test instrument. I just want to make it read a bit more. It's supposed to be the centre of that red patch. So that is the centre of the red patch. So it must have read quite low between the power supply and the actual power on the radio being slightly low. We've done the frequency. Now they want us to check the deviation. Now this was too high, wasn't it, at 3.2? So I was doing some UHF things in between, so we'll just go back to 27 megs, which is about there. Wallow, 1, 2, wallow. So we'll get the little oscillator out. So 3 point something it's showing. Let's pop that down. It's a bit vicious. Testing 1, 2, wallow. 1, 2, 1, 2, wallow. Actually, that's too low, even though it read high. Tell you what we're going to do. Just check that's the right value. I'll just turn the oscillator off. It's 5k it says on it. So it's VR3. Yeah, it's supposed to be 5k, so that isn't the problem. If I can see a tin of Servicol switch cleaner, I think I'm going to borrow it off Mr. Chippy's bench, so we'll just pause the video. Right. One to wallow. That's how we want it. Peak at 2.5. Oh, is mic gain down? No, mic gain isn't down. It just did strike me. So that's deviation back to where it should be, because it was too loud. And that would bleed onto other channels. Unless you're on a Fidelity 1000, where all 40 channels can be heard on one anyway. So, I think that covers the transmit. I'll just check with what the manual says. So, RF meter. So we now move over to the receive. They say what? And they correctly say 100 microvolts for S9, which is nice. Just see if the specs in here. What's it supposed to do? Sensitivity 0.5 microvolts for 20 dB synods. A bit tough. I think it could even be far-fetched, but let's see. Okay, so we're up. We've just set the signal generator. So we're going to start by putting an S9 equivalent signal on and looking at the oscilloscope, because tell you what, it sounds a bit quiet. So if I remember rightly, that's the detector coil, but is it that? Just have to check. T11 is the detector or demodulator, and it's that one, so I'm glad I didn't touch the other one. So I'll switch over to the oscilloscope. We're looking for maximum recovered audio. That's miles out. Okay. So that's now maximum recovered audio. So let's go down the sensitivity line. So you can hear the radio is now louder. Put the bench light back on. Look at the synod meter. So they want you to adjust T5, 6, 7, 8, 9, 10. So 5, 6, 7, 8, 9, 10 in that order. So we've got about 4 dB on the cyanide meter. I can't really see we've made any difference. So put a bigger signal on for those and just recheck. Go back to the first one. Okay. Let's get a reading. So I want enough signal for me to read 12 dB. And then we'll look at where that is on the attenuator. So we of course, as ever, we're right between scales, aren't we? So it's showing 1 microvolt for 12 dB, and it's, if we change scales, it's showing 0.95 microvolts for 12 dB. Just making sure the RF gain's up, which it is. So it was 1.05 before. Now, we've seen more sensitive ones of these, but that isn't unduly insensitive. So I'm quite happy to put that now 0.95. So the magic 20 figure which they're quoting, yeah, I mean, it's 2.5 microvolts, that, so let's see how well we can hear down to. Well, that's 0.3 of a microvolt. 0.15. Here down to about 0.15 of a microvolt. So the sensitivity is there, but with noise, and that's why you're not getting as good a cyanide reading as could be. Of course, you could change all the capacitors in the receiver for Nikon ones, and if it was still noisy, you could change the transistors. But you know, you start to think it's not going to make any difference. So we'll do a scratchy corner test on this later on today. And the proof of the pudding will be in the eating. Okay, so we're now on a 9, we're looking for S9, so we want to adjust the S meter to read 9. And at the moment, it's banging off the scale, so that needs to come down. So one of these is squelch, and the other one, I think that's the meter. In fact, without looking it up, I'll adjust that. Yeah. So that's S9. So now we just need to check the squelch, and that's somewhere where this can be a bit let down. Well, the other side, but isn't the 134? It's not the best squelch in the world. So squelch to full. That's a bit noisy. Something else we could do with spraying. So what we'd like to happen is that when I go up to 100 microvolts, it comes in. Well, it's coming in at 10 microvolts, which isn't too scary. Let's see whether we can get any more. That's full. No, 30 microvolts or 25 microvolts is the maximum squelch you can do on this radio. But of course, with it having RF gain, you could still squelch things out by turning down the RF gain. So that's fair enough. Let's look at it at the sensitive end. So we'll turn the signal generator to standby. If you see the red light there, that shows us the signal generator is in standby, and it's at 0.3 of a microvolt when it does come on. So we're going to turn the squelch control. We're going to turn the squelch control. It's not coming in at all, so we're going to have to do a compromise and advance that slightly. That's there. Okay. So we'll set threshold, and when does it come in? It comes straight in, 0.3 of a microvolt. Goes off at 0.14 of a microvolt, comes in at 0.31 of a microvolt. So it's nice and sensitive. We'll read the top value because having had to adjust the preset, we've now altered that. You know what? It's improved it. Now how come? It's just this again. So there's our 30 microvolts. Let's check it again now at the sensitive end. Stand by. Still just as sensitive. And coming into 100 microvolts. So we've actually set that up pretty well. That's interesting that although the right hand position is the more sensitive end, the left hand position you expect to be the tightest squelch, but actually the better performing squelch is where it is. Oh well, you live and learn. So that covers that. That is done. So I'll tell you what, I'll pop the lids back on. And that's made a nice radio. I don't think this customer's got any shortage of radio. I think he's got quite a quantity. The only trouble is, between last week and this week, where did I put the screws? The big ones in my on my computer because of me ordering last week. So just check these. They're probably all right, but it is always prudent to change them at this value, at this age. In circuit. Oh right, well that one's duff. So I'm glad we've changed that. and that's 50 microfarads. Should be 47, that's fine. So I'm glad we changed those because one was duff. Great. Definite result there. Right, his screws. So in concluding, this eBay radio sold as spares or repairs without a microphone, capacitor in the power supply duff, not slightly off frequency, still very, very slightly off frequency, but well within spec. Deviation miles out, power output a bit low. Just needed that 38-year service, didn't it? Clearly it's had the magic screwdriver in it on that deviation. Just take that adapter off because that's a walkie-talkie adapter. Here goes. Well, no, Roger. Roger. No, there you go. Right, we'll do a scratchy corner test later on today, and that can go back to the customer. Thank you for watching the Harvard H407 407, which has taken me a week to get that power supply capacitor.